Hello students, welcome to Boundless Maths, your trusted space for both maths and science. In today's video, we are going to cover how to approach trigonometric proof questions for class 10. Before we get into the details of the proof questions, let's first have a recap of the basics of trigonometry. So the first thing we learnt in trigonometry was pause, breathe, proceed, helping hands, balance. So this helps you to learn the definition of all the basic trigonometric ratios: sin theta, cos theta, tan theta, cosec theta, sec theta and cot theta, right? After that we learnt about the trigonometric identities. sin²A is plus cos²A is 1, sec²A is 1 plus tan²A, cosec²A is 1 plus cot²A, right? And then we also had a look at the magical hexagon. Tan theta is sin theta by cos theta, sin theta is cos theta by cot theta, cos theta is cot theta by cosec theta. So we are going to use all these things. Sin theta is also tan theta into cos theta. So all these might also help you when you are doing the proof questions. So out of all these conversions and relations between the trigonometric ratios, the most commonly used are these only. Cosec theta is inverse of sin theta, right? Sec theta is inverse of cos theta. Tan and cot are inverse of each other. Tan theta can be written as sin theta by cos theta and cot theta can be written as cos theta by sin theta. So once you are thorough with these basics, this is what we are going to use for doing the proof questions, these identities and the basic conversions between or the relations between the various trigonometric ratios. So let's have a look at few questions from exercise 8.3 of your NCERT book. So the first approach to solve these proof questions is keep a watch on the right hand side what you need to prove. Accordingly modify the left side. So most of the questions, the easy ones, they would have something in the form of sin theta or cos theta on the right side. So from the left side, convert everything to sin and cos and just keep on simplifying, you will reach the right side. So let's start with the first question. Cosec theta minus cot theta whole square is 1 minus cos theta upon 1 plus cos theta, right? So we will start from the left hand side. So the left hand side says, what is cosec theta in terms of sin? Because we need to convert everything to sin and cos and then keep simplifying. So cosec can be written as 1 by sin theta. Cot theta can be written as cos theta by sin theta and it is whole square. If I take the LCM for both the terms, it becomes sin theta in the denominator and in the numerator I have 1 minus cos theta and everything squared. So both the numerator and denominator can be separated out, 1 minus cos theta whole square upon sin² theta. Now whenever you have square of the ratios, think of identities. Can they be replaced with the identities? Yes. So in this case, the denominator can be written as what? 1 minus cos²θ using the first identity. sin²θ plus cos²θ is 1. So that means sin²θ can be written as 1 minus cos²θ. Now the numerator has 1 minus cos theta 2 times. And in the denominator a square minus b square, that means a plus b into a minus b. So one of the bracket gets cancelled and whatever is left out is what we have on the right side. So this is equal to the right hand side. Easy? So let's have a look at another question, question number 2. Now here the right side has 2 sec²A. That means it can also be thought of as 2 upon cos²A. So if we convert everything to cos²A or somehow we can get cos² from the left side, so the work will be done. So let's start with the left hand side. Now because we have two separate terms, so we'll start by taking the LCM of these two terms and then simplify further. So what is the LCM of these two terms? If I just put the brackets, the left side becomes cos² multiplied by 1 plus sin²A. It should be A here, A is missing. Okay. Now when you take the LCM, you create a cross. So numerator becomes cos²A plus 1 plus sin A whole square, right? Open the bracket using the first identity, first algebraic identity, a plus b whole square. So that is a square plus b square plus 2 sin A, and hold this upon the denominator remains the same, cos A into 1 plus sin A. Now in the numerator, cos²A plus sin²A becomes equal to 1. So the numerator we have cos²A plus sin²A makes it 1, and this 1 makes it 2. So it becomes 2 plus 2 sin A upon cos A into 1 plus sin A. From the numerator, take 2 common out, it becomes 1 plus sin A upon cos A into 1 plus sin A. Now this bracket 1 plus sin A gets cancelled. So this is what I have on the right side, 2 upon cos A, and cos A can be written as sec A, and this is the right hand side of my question, right? Easy. So convert everything to sine and cos, and if it is already in sine and cos, just simplify and you will reach your right hand side. So let's have a look at the third question. Now here we have tan and cot on the left side and sec and cosec on the right side. So sec and cosec, indirectly they mean sine and cos only, because cosec is inverse of sine and sec is inverse of cos. So basically if we start simplifying from the left side, in terms of sine and cos, we will reach the right side. So let's see. So left side, tan theta can be written as sin theta by cos theta, and cot theta can be written as cos theta by sin theta, right? Similarly for the next term also, cos theta by sin theta upon 1 minus tan is sin by cos theta, right? Simplified further, so we will have sin theta by cos theta, and in the denominator we will have sin theta minus cos theta upon sin theta, plus the second term will be cos theta upon sin theta upon, this is cos theta minus sin theta upon cos theta, right? Let's keep on simplifying. Now here be very careful when you have a fraction in the numerator also and denominator also, right? So this becomes sin theta upon cos theta. Think of it, this fraction is being divided by this, so it will be multiplied by reciprocal of the denominator. So that means we have sin theta here and sin theta minus cos theta here, right? Plus cos theta by sin theta. Again this fraction being divided by this fraction, so do the inverse of the denominator, multiply by inverse of denominator, cos theta upon cos theta minus sin theta, right? Now here we have sin theta minus cos theta, here we have cos theta minus sin theta. If we take minus out from this, I take minus out from this bracket and I change this plus sign to minus sign. So then this becomes what? This bracket will become sin theta minus cos theta. In place of cos theta minus sin theta, I will have sin theta minus cos theta, right? Now it is easier for me to take the LCM of these two terms. So what do I get? If I take the LCM, I have sin theta minus cos theta, which is a common factor between both the denominators. Next I have cos theta from here and sin theta from here. So it is cos theta and sin theta. Now cos theta and sin theta minus cos theta are already there in the first fraction. So what do I do? What do I have extra is sin theta. So the numerator will be multiplied by sin theta. So it becomes sin cube theta minus, similarly this term will get multiplied by cos theta. So it becomes cos cube theta. right? Now, do you know the identity for a cube minus b cube? How do we use that? A cube minus b cube is a minus b, yes. So, it is going to be a minus b sin theta minus cos theta, and the second bracket will have sin²θ plus cos²θ plus sin theta cos theta, right? Denominator is the same. We have sin theta minus cos theta in the bracket, and then we have cos theta into sin theta. So, this bracket gets cancelled. In the second bracket, sin²θ plus cos²θ is 1. So, we have 1 plus sin theta cos theta upon sin theta cos theta, right? Now, you just separate out both these expressions into two fractions. One will be this and the other will be this. So, what do we get? We get 1 upon sin theta cos theta, and the second one will become, everything will get cancelled, so it becomes 1. So, basically we have 1 plus 1 upon sin theta is cosec theta, and 1 upon cos theta is sec theta. So, this is what we have on the right side of our question. Yes, 1 plus sec theta into cosec theta. So, we have proved from left side we reach the right side just by converting everything to sine and cos and then simplifying. Clear? Wonderful. So, let us move to the next question. Okay, now right side has sine and cos and left side has only sec. So, let us start by simplifying the left side and see if we can reach the right side, because this does not look like a simplified version where something is being added and subtracted. So, it is a fraction that also denominator with two terms. So, we might need to simplify LHS and RHS separately. So, the first approach is, if the right side is a simplified version of sine and cos, left side convert everything to sine cos and keep on simplifying, you will reach the right side. But if you feel the right side is not directly reachable or it is not a simplified expression, then you try simplifying both left and right side separately. So, let us start with the left hand side. Now, on the left side we have 1 plus sec A can be written as 1 upon cos A, and in the denominator also 1 upon cos A. Again I am repeating, when you have fractions both in numerator and denominator, please be very careful. So, how do we do that? Simplify the numerator first. It becomes what? Cos A plus 1 upon cos A divided by 1 upon cos A. So, the numerator is a fraction, denominator is a fraction. It means the numerator divided by denominator or numerator multiplied by inverse of or the reciprocal of the denominator. So, this can be written as cos A plus 1 upon cos A multiplied by cos A upon 1. So, this cos A gets cancelled and we are left out with 1 plus cos A. But on the right side we have something different. We have sin²A also there on the right side, which can easily be converted to cos A. So, let us see how do we simplify the right side. So, on the right side we have sin²A upon 1 minus cos A. So, sin²A can be written as 1 minus cos²A. Wonderful. So, 1 minus cos²A upon 1 minus cos A square minus b square. So, this makes it 1 minus cos A into 1 plus cos A upon 1 minus cos A, right. Now, this gets cancelled, 1 minus cos A. So, we are left out with 1 plus cos A, which is same what we got on the left side. On the left side also we got 1 plus cos A. So, that means we can say the left side is equal to the right side, and hence the question is proved. Easy? Okay. So, let us move to the next question, question number 5. Now this is a very special question. Please put a star here and practice it at least twice. This is a very special question here. The question is cos A minus sin A plus 1 upon cos A plus sin A minus 1 equals cosec A plus cot A, using the identity cos²A equals 1 plus cot²A. Now this question is very important, and this is very much similar to the last solved example given in your textbook just before this exercise. So let's see how to approach such questions. We start from the left hand side. Left side we have cos and sin, but we need cosec and cot. What is cosec? Cosec is 1 by sin and cot is cos by sin. So if I divide all the terms of the numerator and the denominator on the left side by sin A, cos by sin will give me cot, sin by sin will become 1, 1 by sin will give me cosec. So somehow I will start getting cosec and cot, and then I will see how to simplify further. So the first step on the left hand side is I divide numerator and denominator by sin A, right. So cos by sin becomes cot A, sin by sin is 1 and 1 by sin becomes cosec A. The denominator becomes cos by sin is cot A, sin by sin 1 and 1 by sin is again cosec A. Now at least I got cot and cosec, which I need on the right side. Now the question says use the identity. So if I look at this one and this one, I can use this identity here. So how do I use that? If I leave this one on the right side, I have cosec² minus cot² equals 1. Yes? So now in this expression, I will just shuffle the terms, not doing anything, no changes at all, just that I have changed this placement. Cot A plus cosec A minus 1, I keep it separately. Denominator stays as it is. The denominator is very sweet and it will just stay as it is without disturbing you at all, because in the end it is going to get cancelled. So you don't have to do anything with the denominator, let it be whatever it is. Now in the numerator, in place of this one, I have to use this identity, right. So my expression becomes cot A plus cosec A, and in place of 1 I have to write cosec² minus cot². Denominator simple and cute as it is, no changes at all, just retain it the way it is, it will get cancelled. In the numerator now I have a square minus b square, so I can expand this bracket and write it in terms of a plus b and a minus b, right. So the first part of the numerator is the same, no change at all, just that I have added a bracket here. Second part has cosec A plus cot A and then cosec A minus cot A, right. Again the denominator will stay whatever it is, cot A minus cosec A plus 1, let it be, right. Now I have two blocks of expressions in the numerator, one is this and the other one is this. In both these blocks I have cot A plus cosec A common, right. So I can take it out the way you do, when we are doing factorization by splitting the middle term, we take the common factors out. So here take this common factor out and what we'll have? We have cot A plus cosec A, it is out now. From the first block I am left out with 1, don't ignore this one, minus, I will put a minus stays there. Second block I have cosec A minus cot A, right, and the denominator again stays as it is, no change at all, because it is going to get cancelled in the next step now. So in the numerator cot A plus cosec A, and the second bracket has 1 minus cosec A plus cot A, which is what I have in the denominator also. So the denominator is also cot A minus cosec A plus 1, and both these brackets they get cancelled. So what is left out is cot A plus cosec A. This is what I have on the right side of my question. Can you see? It is the same thing, cosec A plus cot A. So this question is very important, and it has to be solved like this only, where you have to use an entity in place of 1, use a square minus b square, take a plus b out, common out, and rest of it will get cancelled and you will be left out with the right hand side. So the question is very much similar to the last solved example. I am repeating, this is a very important question. Please do it carefully, attempt it at least twice so that you get the hang of it, right? Okay, wonderful. So let's move to the next question, that is question number 6. Now here we have sine on the left side and we have sec and tan on the right side. So how do we do that? Sec and tan can be easily simplified. Secant is 1 by cos, sine is sine by cos, easy. So we will just divide our space into 2 parts because we need to simplify left and right side separately. On the right side, let's first simplify the right side and keep what we need in place in terms of sine and cos. So we have 1 by sec A means sec A means 1 by cos A, and tan A means sin A by cos A. So in terms of sine and cos, if I need this, it is 1 plus sin A upon cos A. Now just keep it aside. This is what we need to prove. So let's start with the left hand side. Under the radical sign we have 1 plus sin A upon 1 minus sin A. So let's first rationalize this. This becomes 1 plus sin A upon 1 plus sin A. When you have such expressions, always start with rationalizing when the denominator has two terms being separated by a plus or a minus. So in the numerator now we have 1 plus sin A whole square, and in the denominator is a square minus b square. So it becomes 1 minus sin square A, the whole thing under the radical sign. In the denominator I can again use the entity 1 minus sin square is cos square A, wonderful. So it is 1 plus sin A whole square upon cos square A and everything under the root. Now this square and square root will get cancelled, so I have 1 plus sin A upon cos A, and this is what I have on the right side also. So that means my LHS is equal to RHS, hence proved. Easy? Wonderful. So let's move to the next question, question number 7. In this question we have sine and cos on the left side and tan theta on the right side. Now the left side expressions, if you look at it carefully, you can take sin theta common out from the numerator terms. So I have sin theta and then 1 minus 2 sin square theta. In the denominator I can take cos theta out and I have 2 cos square theta minus 1. If you compare it with the right side, what we need is tan theta, right? And sin theta by cos theta is tan theta. So if somehow we get rid of both these brackets, we have what we need on the right side. So let's see how do we get rid of these two brackets. Either you convert sin square theta into 1 minus cos square theta, or you change cos square theta into 1 minus sin square theta, both will work. So the left side becomes, I can write sin by cos as tan. So let me keep it as tan theta only, which is what I need on the right side, and try to simplify rest of it. So it becomes 1 minus 2, and I am writing here 1 minus cos square theta. You can even change the cos square theta of the denominator to sin square theta, it will work, don't worry, right? So it is cos square theta minus 1, wonderful. Now just open the brackets in the numerator and simplify. 1 minus 2 and then plus 2 cos square theta upon 2 cos square theta minus 1. So this bracket in the numerator can be written as 2 cos square theta minus 1, and in the denominator I have the same bracket 2 cos square theta minus 1, which gets cancelled. So I am left out with only tan theta, which is my right hand side, hence proved. Easy? Great. So let's move to the next question. Now again, this is a very important question. Put a star and think how to do it. On the left side we have sine, cosec, on the right side we have tan and cot. If you want to give it a try, pause this video right away, give it a try. And if you don't understand how to do it, let's proceed. On the left side, I'll just open both the brackets using a plus b whole square. How do we do that? This becomes sin²A plus cosec²A plus 2 sin A. Cosec can be written as 1 by sin. So, I'll write it as 1 by sin so that you can see how they get cancelled. Sin and sin gets cancelled here, right? Plus, expand the second bracket also, it becomes cos²A. So, this becomes cos²A plus sec²A plus 2 cos A, and again I am writing sec A as 1 by cos A so that you can see that they get cancelled. Now I have 2 here, I have 2 here, and sin²A plus cos²A gives me 1. So that means I have 2 plus 2 4 and 1 from sin²A and cos²A, so I have a total of 5. Write 5 here. Next what I am left out with is cos²A plus sec²A. Now when you are doing this, on the right side you have tan² plus cot² and left side is cosec and sec. So we have identity 2 and 3 to help us out here. So this becomes 5, 5 remains as it is. Cosec² is 1 plus cot²A, and sec²A is 1 plus tan²A. Wonderful, you remember the identities. So the constants become 7, 5, 6 and 1, 7 plus cot²A plus tan²A, which is what we have on the right hand side, and it is done. Such a simple question. Easy? Wonderful. So let's move to the next question, question number 9. Now here on the right side we have tan and cot, on the left side we have cosec, sin, sec, cos, everything. So the right side is not a simplified version of sin and cos, so that means you should divide your space into 2 parts and simplify left and right side separately. So what is the left hand side? Convert everything to sin and cos and simplify. Cosec is 1 by sin A. Sin is sin A only, leave it as it is. Then sec A is 1 by cos A, and cos A remains cos A. Easy? Take the LCM, this becomes what? Sin A, and the numerator is 1 minus sin²A. Take the LCM here also, denominator is cos A and the numerator becomes 1 minus cos²A. Now open the brackets in the numerator using distributive property. 1 into 1 is 1, 1 into minus cos² is minus cos²A, minus sin²A, and minus into minus is plus, plus sin²A, cos²A, whole upon sin A into cos A. This is what I got, right? Now if I take this minus common out, I can change this into a plus and put a bracket here. Yes, I can do that. I have just taken minus common out of these two terms. So cos² plus sin² is 1. So that means this 1 can be cancelled out with this one. This is 1 plus 1 and this is minus 1. So they go away. So what is left out is sin²A, cos² upon sin A and then cos A. One of the terms gets cancelled with the denominators and I am left out with sin A into cos A. Okay. Now let's have a look at the right hand side. So the right hand side is 1 upon tan plus cot. Convert both of them to sin and cos and simplify. Very simple. So it is sin A upon cos A plus cos A upon sin A. Take the LCM. So this becomes cos A sin A in the denominator, and we have sin²A plus cos²A. Sin²A plus cos²A is 1. Excellent. So it is 1 upon sin A into cos A. So that means my right side is also sin A into cos A, which is what I got on the left side also. So my left hand side is equal to right hand side. If you don't understand this step, just think of it 1 divided by 1 by sin A into cos A. So 1 multiplied by inverse of 1 by sin A into cos A. So that becomes sin A into cos A. Understood? Easy? Wonderful. So whenever you have two fractions, especially the denominator is a fraction, think of it numerator divided by denominator. So that means numerator multiplied by ulta, reciprocal of the denominator. So that will make your work easier. So coming to the last question of this exercise, this is the last question and it has 3 expressions to be proved to be equal, right? So we can first prove that this is equal to this and then the second and third expression, they are also equal, right? So let's start with the first left hand side. 1 plus tan². Now because we have tan²A on the right side, so we can retain tan²A here and only convert cot to tan and then simplify. So the left becomes 1 plus tan²A upon 1 plus 1 upon tan²A. Yes? Take the LCM and let's simplify. The numerator will stay 1 plus tan²A. Denominator is, take the LCM, tan²A plus 1 whole upon tan²A. Again, there is a fraction in the denominator. So numerator multiplied by reciprocal of the denominator and 1 plus tan²A will get cancelled. So what is left out? Only tan²A, and hence prove this is equal to what we have on the right hand side. That is the third expression. Wonderful. Easy. Yes. Yes, it is easy. Now let's look at the second expression. So what do we have on the left hand side in this case? 1 minus tan A upon 1 minus cot A and whole square. So again, let tan A be tan A because we need it. Cot A convert to tan A and let's simplify. So it is 1 minus tan A upon 1 minus 1 upon tan A. Again take the LCM. 1 minus tan A stays there in the numerator. Denominator we have tan A minus 1 whole upon tan A whole square. Entire thing squared. Now if you compare the brackets in the numerator and denominator, there is a difference of just a minus sign. So if you take minus sign out of this denominator, I have the same thing, 1 minus tan A upon 1 minus tan A upon tan A and then whole square. So now 1 minus tan A gets cancelled with 1 minus tan A. Again numerator divided by fractional denominator, so numerator multiplied by reciprocal of the denominator. So this becomes what? There is a minus sign also. So this becomes minus tan A whole square, and which is same as tan²A. So we have proved that the first expression is equal to the third one, and on this side the second is also equal to the third one. That means all three of them are equal. Done? Excellent. So I hope you understood how to approach trigonometric proof questions. The problem is we feel they are very difficult. No, they are very easy. Just convert everything to sine and cos and keep on simplifying. If you do not get the right side directly, simplify the right side also separately. But question number 5, it was a little different with a different approach, similar to the last solved example where you have to use an identity. Be careful on that question. Rest of the questions are very simple, right? So practice this exercise at least twice so that you get used to doing these questions. If you like the video, if the video really helped you, don't forget to like the video, share it with your friends who can also get benefited, and subscribe to boundlessmaths.com to keep getting updates on new videos that are getting uploaded. Right? Till then, keep learning, keep growing. Thank you.